Alright, this is a go. Hello, everybody, and today we'll be talking about three things about functions. So these three things are cubic functions, rational functions, and transformation. So these are the three things. They're all related to functions, the unit functions. I'll just put it right here. So without further ado, let us begin. So, cubic functions. So cubic functions usually look like this. So it's like a quadratic, but there's more degrees. Like for quadratics, there's only x squared, but for this one, it's cubed. So this is the usual format for a cubic function. So now that we know how a cubic function looks like if you put it in this way, so how does it look like in a graph? So it looks like something like this. Sorry for the crappy drawing. It's gonna look something like this. This is called a cubic curve. So in questions that ask you, oh, what function does this graph belong to? If you see a shape like this, then it's a cubic function. Other varieties include something like this. It depends on the multipliers on each of the um, x's of the variables, like a, b, and c, and d. So some cubic functions may look like this. This is the how y equals to x squared looks like, or even looks like this, where cubic function only has two roots or one root. But the shape usually looks like this. It's just this is a cubic curve, or this. So, what is the range and domain of a cubic function? So the domain and range of a cubic function is simply. Hold on, let me write this down. I should really type that out. Hold on. The domain equal to this is why I might need to draw this out. It's a real number. So the domain that is that it can be any real number. The range is the same. Let's type this one out. Range equals to wait, why is it x? Hold on. Sorry about that. It's supposed to be in y. Let's just erase that. Hold on. The range is that for any y value, it's a real number. There you go. Alright, so just emphasizing because of this crappy drawing, this sign is this sign. So this sign symbolizes that the value of y belongs to that group, belongs to that set, and the R means the real number set. Alright then. So there are a few things to note about the cubic function. Is that there are some questions that will question you on the local minimum and the local maximum. So what is the local minimum and the local maximum? I might refer to the previous graph. So like here, this is the local maximum, and this is the local minimum. All right. So look at this. This point is the local maximum. This one's the local minimum, the extreme. Whereas like it stops and then it just goes down, and this one just stops decreasing and increases. So what about if we put a negative sign to the function and it gets switched like this? Well, as you can see, this is the local maximum, and this is the local minimum. And just write it down, max. So when it asks you about the local maximum and local minimum, you just put up a calculator, search it, or click on extremum, and the extremum will be either the local maximum or local minimum, and just the deeper one is the minimum, the one on top is the maximum. And this is basically cubic functions. So let's just move on to rational functions. Wait, hold on. New, save. Right, rational functions, here we go. So for a rational function, in its most basic form, this is a rational function. So how does a rational function most likely looks like? Let me draw a graph for you. Hold on. There you go. For the graph of 1 over x, it looks like this. This is a rational function. And notice like how the line, it never reaches the x-axis or the y-axis. Why? Because let's assume that the x-axis, the x is equal to 0. So you substitute x of 0, and well, you're just dividing by 0, which is well impossible. And why does it never reach the x-axis is because if you divide 1 over infinity, which is like, x here, never reaches. That's because even though 1 is being divided by infinity, it cannot be divided to 0. It still has some more. It still has a extreme small number, but it's not 0. So in this case, for this graph, let me just erase this first. Y equals to 0 and x equals to 0. This is the vertical asymptote, and first asymptote. I might as well type it. Hold on. And this is the horizontal asymptote. There we go. So these are like the lines that the function will never reach. So what is the domain and range of 1 over x here? So the domain it will be equal to well, of course, the domain is that x will be any of the real numbers, but x will not equal to 0. The same goes true of y. So right here, range the y will be a real number, but it will not be equal to 0. So let's say here's a new function. Let's say 1 over 2x plus 1. So how do we actually find the vertical asymptote and the horizontal asymptote? Well, you see, to find out the vertical asymptote, we need to set the denominator to 0. So 2x plus 1 equals to 0. We just need to solve this equation. So we now get that x equals to negative 1 over 2. This is the vertical asymptote. So keep in mind that v dot a is just basically x equals to negative 1 over 2. How about the horizontal? So for the horizontal, there are 3 rules. Is that if the numerators, the degree, the x in the numerator, the degree is lesser than the 1 in the denominator, then the horizontal asymptote is going to be 0. However, if the vertical asymptote is the same, then not the vertical asymptote is the same. Sorry about that. The degree is the same on both the numerator and the denominator. Then it's just going to dividing the multiplier on each side. So you divide the denominator, the multiplier on the numerator with the one in the denominator. So I'll demonstrate this later on. So here in this function, you can see that the degree in the numerator is lesser than 1 of the degree in the denominator, because it's just 1, while this one has a variable, so it is lesser. So the horizontal asymptote is going to be y equals to 0. So now the domain will be x is belongs to real number, but x will not be equal to negative 1 over 2. Range will be y belongs to real number, but y will not be equal to 0. So for another case where there is x present on the numerator and the denominator. So let's say x plus 1, 2x plus 1, x minus 3. Let's say this rational function. What is the vertical asymptote? x minus 3 equals to 0, x equals 3, that's the vertical asymptote. How about the horizontal asymptote? So, horizontal asymptote. As you can see, the degree on x is on the numerator and the denominator, they're the same. They're 1. So, the horizontal asymptote is going to be dividing the multiplier on both sides. So, y equals to, what is the multiplier on the denominator? It's 2. So, 2 divided by 1, because the multiplier on the x on the denominator is 1. So now the horizontal asymptote is 2. So now we figure out the domain is x belongs to a real number, but x does not equal to 3. And for the range is y, it belongs to a real number, but the y cannot be 2. And that's how we work it out. We're basically done with horizontal. We're basically done with rational functions now. For instances where the degree of x is larger in the numerator and than the denominator, you don't need to really learn about this. You only learn about this in IB, and you can work out the horizontal asymptote using long division. So let us finally continue to transformations. Alright, cool. We're only 17 minutes in. We're going fast. This might be one of the shorter lessons. Transformation. Alright, so there are a few transformations you need to know. Let me get my notebook and I'll list it out for you, people. Hold on a second. Ah, there we go. Right here. So, transformation. The first one is y equals to f of x. Sorry. There we go. F of x plus a. So what happens here is that the function will go up by the a amount of digits. So how about if f of x minus a, then it'll go down vertically by a's amount of digits. Alright, all clear? Let us move on. How about y equals to f of x minus a? Then now the function will move horizontally to the right by a digits. If you change the case of the bit, say x plus a, then it will move in the opposite direction by a digits. So in this case, it means the left. Moving on, y equals to a f of x. So now the function will stretch vertically by a factors. So it's stretching in the y direction. Another transformation is y equals to f(ax). So now the function will stretch horizontally but this time with the factor of 1 over a. Remember, 1 over a. You must keep in mind of that. So it stretches in the x direction. Then we're moving on to y equals to, hold on, let me type this out. Right. Y equals to minus f of x. This is just a reflection of the x-axis. So normally, alright, let's suppose this is the x-axis. X-axis. This is our function, our initial function. And the transformed function will look like this. So it's just a reflection of the x-axis, like this. We are going to move on. So the transformation will be y equals to f minus x. This so as opposed to the this one, which is just reflection of the x-axis. This transformation is reflection of the y-axis. So let's say your initial function looks like this. The transform function will look like this. So as you can see, it just got reflected off the y-axis. And that is all the transformations you need to know. Alright, I'm just gonna let you take some time to absorb this. It seems relatively easy, right? Alright, let's move on. So there are some questions that will ask you to describe the chain, the transformation. So let's say, describe the transformation from y equals to x squared to y equals to x squared minus 4x plus 3. So how do you do this? So preferably, you should convert the this function, all right, to a like the complete the square format. I remember. So if you transform this to like that, it should look like x minus 2 squared minus 1. So this is like the complete the square format of a quadratic function. So now you actually see more clearly. First of all, let me note this down. X squared, and move something like this, right? X minus 2 squared. So as you can see, this is moving in the x direction. Move, or should I say the translation of the function. Let me just type this out to be more clear. So, translation on the x-axis by 2. Then, this. And this is just, as you can see, is minus 1, right? So it's just translation on the y-axis by negative 1. Just like that, we got it. So when asked to describe the transformation, you say that from x squared to this one, it should be translation by the x-axis by 2, and then translation on the y-axis by negative 1. Or you can say that it is translated, or let me type this up, translated, or translation with the vector to -1. You can also write it like that. But if you want to be more detailed, you can say translation of x-axis by 2, translation of the y-axis by -1. You can say that. So this is it on transformation, and that's it. You just have to remember all these transformations, and you know how to describe them. And yes, this is it. This is the end of the lesson, and next lesson we will go on to indices rules, logarithmic rules, and also some trigonometry on next lesson. So stay tuned. Right. Thank you everyone to who is watching my video. So yeah, this is it. Goodbye.